Hi there, and welcome to this lesson. In this lesson, we'll be learning quadratic equations. Okay, and under quadratic equations, we'll be learning to solve simultaneous linear and quadratic equations. So, as the name suggests, basically a set of simultaneous equations usually contains one linear equation, one quadratic equation. Very easy stuff. Easy stuff. So, as the lesson progresses, anything you don't understand, be sure to get across to your tutor, who would be more than happy to help. And yes, let's jump right into the lesson. So, quadratic equations, simultaneous linear and quadratic equations. Now, consider the set of simultaneous equations below. So we have equation 1 as 3x squared minus 4y equals minus 1. And then we have equation 2 as 2x minus y equals 1. Now, what we have here, we have a set of simultaneous equations, and as you can see clearly, we have some quadratic properties in the first. We have two variables at play, okay, but then we have x squared, and x squared complicates matters, okay. X squared makes things interesting. Now, what we have here is we have a set of simultaneous linear and one quadratic equation, and we're looking to solve this set of simultaneous equations. We usually take a very interesting approach to solving these. Now, the first thing we need to do here, first of all, when you're solving simultaneous linear and quadratic equation, you solve by method of substitution. We cannot solve by method of elimination, okay. We always solve by method of substitution, and we start off with the linear equation, okay. And here's the first thing I'm going to do here is, and we prefer to use, when you're working, make work start off with y, okay, because x is somewhat conventional, so it's better you working with x. You can work with y. Basically, you understand exactly what I'm talking about shortly. So first of all, start with the linear equation, okay, and then when you make y the subject of formula in the linear equation, that's the first thing you need to do. Now you have that y equals 2x minus 1. The next thing you want to do is you want to substitute this into your other equation, into the quadratic equation, and basically you have 3x squared minus 4y, i.e. minus 4 2x minus 1, because y equals 2x minus 1 equals minus 1. From this point on, you just expand and you simplify, and you should end up with a quadratic equation, a straightforward, simple, standard quadratic equation with just one variable, x, okay. So in this case, you have 3x squared minus 8x plus 5 equals 0. And now you can go ahead and solve by method of factorization. You should end up with 3x minus 5, x minus 1 equals 0, which will tell you that x equals 5 over 3, or x equals 1. Okay, so we found our values for x. Now when you solve a set of simultaneous linear and quadratic equation, you always end up with two sets of answers. Okay, so basically you have x equals 5 over 3 and x equals 1. For each of these x's, we have the y values, okay. And basically we have the y. You just remember how you solve regular simultaneous equation. When you get x, you then substitute your value for x to get y, okay. And this time around, we have the y equals 2x minus 1. So we just substitute each of the x values to get y. So we have x equals 5 over 3. So 2 times 5 over 3 minus 1 would give you 7 over 3. So y in this case is 7 over 3. And then x equals 1. So 2 times 1 minus 1 gives you 1. So y equals 1 in this case. And this is your final answer. So you have x equals 5 over 3, y equals 7 over 3, x equals 1, y equals 1. And that is how you solve a set of simultaneous linear and quadratic equations. Simple equations, simple, straightforward. Now let's do a few examples. So example 1. In example 1, we have solved the set of simultaneous equation 3x plus y equals 25 and xy equals 8. Okay, so there really isn't a quadratic. We don't have any x squared here, but you can see that in the second equation here we have x multiplying y. that complicates matters. Okay, that makes things interesting. But what we have, the first equation, 3x plus y equals 25, is your standard linear equation. Okay, linear way with two variables. So pretty much the standard way you're solving regular simultaneous equation. The x multiplying y, xy equals 8, is what makes this set of simultaneous equations interesting. Now, like I said, start off with the simple linear equation, okay, and then start off with a simple linear equation, and then make y the subject of formula. So and from 3x plus y equals 25, we're going to make y the subject of formula there, and basically we have that y equals 25 minus 3x. That's the first bit. The next thing you want to do is you want to substitute your value for y into the other equation. So we have that x multiplying y equals 8, and we have y equals 25 minus 3x. So what you have is you have x multiplying 25 minus 3x equals 8. And you just go ahead and expand that. So you have 25x minus 3x squared equals 8. And as you can see, we're approaching, and we've definitely arrived at a quadratic equation. Okay, and we just go ahead and solve by method of factorization. You should end up with 3x minus 1 x minus 8 equals 0. So you have that your x equals 1 over 3, and then you have your x equals 8, and then finally you just go ahead and substitute your values into what you have there. Oh, I think we're missing something here. Substitute your values into what you have there, and you should end up with your values for x and y. Okay, and yeah, that's it. Let's do a few more examples. Example 2. Okay, and we have solved the set of simultaneous equation x squared plus y squared equals 34 and x plus y equals 2. Pretty much the same process. Okay, and then basically we have x plus y equals 2. We start from there. Y equals 2 minus x, and then we substitute our value for y into our equation there, and what we have is we have x squared plus 2 minus x all squared. So we have y squared, so we have 2 minus x all squared equals 34. And then we expand that, we have 4 minus 4x plus x squared equals 34. And then we just bring all of that together. We should have 2x squared minus 4x minus 30 equals 0. We'll go ahead and solve this by method of factorization, and we have 2x plus 6x minus 5 equals 0. And then what we have in the end is we have x equals minus 3, x equals 1. We'll go for our y values. We have that y equals 2 minus x, and then when x equals minus 3, y equals 5. Okay, so 2 minus minus 3 gives you 5. And then when x equals 5, is actually very interesting. When x equals 5, you have that y equals minus 3. And that's it. Simple, straightforward. One final example, and it gets interesting here. Okay, pretty much the same process. So we have solved the set of simultaneous equation x squared minus y squared equals 27, x plus y equals 3. Now there's something very special about this set of simultaneous equation, and this is the only form of linear quadratic simultaneous equations that you can actually solve with the elimination method. Now the reason for this, and it's something you should always try to look out for, whenever you have x squared minus y squared, whenever you have something that could possibly conform to the law of difference of two squares, because the questions often come in that form, you always have something interesting there. Okay, so what we have here is we have, if you look closely, you'd find that equation 2 is a direct perfect factor of equation 1. Reason being, you can divide x squared minus y squared by x plus y, okay, and you can divide 27 by 3 quite easily. So what we're going to do here, we're going to do something very interesting, because x squared minus y squared by the law of difference of two squares is x plus y x minus y. Okay, so you have x plus y x minus y equals 27, and we're going to divide that by x plus y equals 3. Okay, and we'll just cancel that out, and what we're left with is we have x minus y equals 9. So what we've done now is we've actually obtained a third law, a third applicable law, okay, that governs the relationship between the variables in these equations. So you have that x squared minus y squared equals 27, x plus y equals 3. From division, we've also found that x minus y equals 9. Now what I can do at this point is I have three equations, and I can pick any two out of the three equations to solve this set of simultaneous equations. And what I'm going to do, I'm just going to pick the two linear equations because they're the easiest to work with. Okay, and at this point I'll just go ahead and I can actually solve this by elimination and subtract equation 2 from equation 1. What I have in the end is I have minus 2y equals 6. I have that y equals minus 3, and then I just substitute these values, and I should have my value for x. My x is 6, and what I have is I have x equals 6, y equals minus 3. Now, like I mentioned, this pretty much just has one set of solutions as opposed to the others that usually have two. The reason for this is the fact that equation 2 is a perfect factor. We have, in this case, we have that equation 2 is a perfect factor of equation 1. And when you're looking at the questions, this is the one exception. Every other thing you solve by the standard process. This is the one exception. And when you're looking, when you questions like this come, when you're faced with questions like this, they usually have something to do with the law of difference of two squares. So if you see one of the equations looks very big, it's always is a difference. You have two squares, the difference of two squares, you have two squares, a square form of x, a square form of y, you have a difference there. It's often tending towards this. Okay, but for every other form of equation you solve following the standard process, as I've explained in example 1 and example 2. Now, this brings us to the end of this very simple lesson, pretty straightforward. Okay, it actually gets quite interesting when you start plotting graphs of simultaneous linear and quadratic equations, because basically if you plot a graph of a set of simultaneous linear and quadratic equation, basically you have you plot the graph of the quadratic, it gives you a curve, and then you plot the graph of the linear, it gives you a straight line, and what you have, you'd find that the straight line cuts the curve at 2 points. Okay, so they intersect at 2 points, and basically those 2 points are always your x and y values, your respective x and y values, when you solve the set of simultaneous equations, simultaneous linear and quadratic equations. So basically that's pretty much it. Very interesting, very simple. You can go ahead now and attempt questions on the worksheet. Bye for now.